toxicology assessment, pharmacology. We'll also be talking about ethics considerations of omics. So without further ado, I would like to invite the first speaker, Pat Kellner from EFCA, Director at EFCA and pharmacist.
Thank you. Should I sit here or? Okay. Okay, thank you. So, to start with, I would like to thank EFSA for the kind invitation to be part of this nice conference. And to start with, I would like to actually go back to some sort of basics. Need to get used to this first. And then I have divided the presentation into three parts. First on the introduction of gene therapy, and then the regulatory landscape of gene and cell therapy in the EU, and in the end I will give some information about the FPI activities and conclusions. But to start with, I will just go back to the very basics, really. And firstly, you have the genes, which are part of pieces of DNA which code for an instruction. For example, if your eyes are brown or blue and this kind of things. And you can also see here that the DNA is building up the double-stranded DNA chromosomes. And you can also see that the chromosome is part of the nucleus of the cell. And all living things have a genome which is made up of our DNA and contains instructions to build and repair our bodies. And genes, they are the instructions to make proteins, which then was building up the body and also consists of different things, everything from keratin in your hair and fingernails to antibody proteins, which are used to fight infections. And you can see that there is also this kind of starfish, and that has actually 20,000 genes, which is actually the same as humans. If you look more into this detailed picture, if you start with looking at the nucleotide, oligonucleotides, it is then short strings of DNA or RNA, which nowadays you have, at least in the US, some 25 approvals of this kind of products. It's either just a DNA string or DNA or RNA string, which is encapsulated into a container, you can say. And this has been developed, for example, for several drugs for the muscular dystrophy, Duchenne's disease. I think it's Lerna, for example, and you also have for spiral dystrophy, Spiraza, as some example of this oligonucleotide therapies. And you also have then gene therapy that you put the gene into a vector and treat patients with it. And you can also have it ex vivo, that you also take out a cell from a patient and then introduce the gene in the vector So this is then also, as you can see, a part of a cell therapy. So these definitions are not exactly well divided. It goes in each other, you can see here. And the other alternative is, of course, if you have a donor that gives the cells. And one example of this is CAR T therapy, which is heard about, for example, Kymera for treatment of cancer. You also have this kind of cell therapy, and there it's important to notice the difference between autologous cell therapy when you take the tissue from the patient and you manipulate it in some way, or allogenic cell therapy when you have a donor that gives the tissue and you manufacture these kind of cells, and then you can give it to several patients. And actually, if you look at this, it's not that really new. 40 years ago, you were starting with bone marrow transplantation, really. So it's also some very old technique when it comes to autologous cell therapy. And then to keep you awake, I have a question. What is the difference between autologous and allogenic cell therapy? Someone? Yes?
So autologous effect comes from your own body, and allogenic is that you use cells from somebody else, so it's tested?
Yes, that's correct. Thank you. I also would like to show this picture because it's an illustration of the size of different particles or molecules. And the scale here is in nanometer, which is 10 raised to minus 9 meters. And then you can see that the proteins are 1 to 10 nanometers, and cells are 10 raised to 3 to 10 raised to 5 nanometers. So it gives an illustration of the size of the different particles that you are talking about. And a grain of salt, I think you could see. Even if I put on my glasses, I could see a grain of salt, for example. But the other particles I cannot see with my eye. If we look again into the gene therapy, as was illustrated previously, we are differentiated between in vivo transfer and ex vivo transfer, and you have then the transgenic gene that you put into a vector and infuse into the patient. And vectors are quite often different kind of viruses, and you could have different delivery routes depending on what you would like to treat. And the examples there is given is psoriasma, I think, is for treatment for cancer, and luxturna, I think it's loss of sight, if I remember correctly. Then you have this illustration that you take out the cells and you manipulate them and present genes. So this is also an example, but it's both gene and cell therapy, and then you infuse it back to the patient. And then you have some examples of things that just have done Kymera or cancer therapy, and I think that Stimulus is about immunodeficiency. And if you look then at somatic cell therapy, it's again that you substantially manipulate it or have it non-homologous. which is about repairing DNA to alter the cell properties, and then you take off white blood cells or monocyte and have these dendritic cells who present to the antigens, and you add the antigens to get this immune reaction, and by that you could, for example, treat cancer and you give it back to the patient. And I will have an example of a product. And if you then look at tissue engineer product, this is another example for a flower where you take it out from the outer part of the eyes stem cell, and then you manipulate them, and then you transplant it back to the eye. When it comes to cell and gene therapy, manufacturing is quite challenging, and it's different compared to conventional drugs or compared to biologics. And here are listed some of the challenges there, but the main difference between them is that for ordinary drugs or biologics, you produce pharmaceuticals to treat many patients, while for cell and gene therapy it could even be one patient, as was illustrated before in the slides, or quite a few patients, and that comes with a lot of different challenges from regulatory manufacturing challenges, and we'll go into more detail at workshop in the afternoon for those who have volunteered to participate in this workshop. But you can see it's about product classification, genetic modified organism regulation, long-term follow-up plan, registration requirements, complex manufacturing process, potency access, short shelf life, ultra-low temperature storage, and supply chain. So there's a lot of different challenges, but I will not go into details in the interest of time. That was the first more basic part. Do you have any questions on that? No? Okay, then I continue. We'll then talk about the regulatory landscape of cell and gene therapy in the EU. As you can see here, there's a lot of different committees that the European Union have when it comes to all things about the approval of medicinal products. And you have an EMA secretariat in the middle who coordinates all the activities. And if you start with the Committee for Human Medicinal Product, that's the committee that issues the opinion, which up until now the Commission have followed the 99.9% of the cases when they issue the different marketing authorization for centralized approvals. You also have a similar committee for veterinary medicinal product, but that I will not go into any details whatsoever, as we are not working with that at EFPA. We also have a committee for orphan medicinal product, and that is of interest for ATP because a lot of these advanced therapy medicinal products, they are actually orphans, and then you need to have an orphan designation in order to get access to the incentives for orphans that you have within EU. You also have a pharmacovigilance risk assessment committee, which also makes benefit risk assessments when a product is approved as well, not only when you should make a decision if the product should be authorized or not. Committee for herbal medicines, I will not go into details because we're not working on that. And you also have a pediatric committee, which is something that is quite important because you need to have pediatric investigational plans approved in the EU in order to get approval of products. And then I will go into more details on the Committee for Advanced Therapies. And as you can see, the most important task for this committee is to prepare the draft opinion of each advanced therapy medicinal product for the CHMP who adopts the final opinion. It could also help specifically small and medium-sized companies with certification procedure. And one important task which I have to go into some more detail is classification procedure, because you need to know if it's an 18B, and also you need to know if it's a medicinal product. It might be something else, for example a medical device. And it contributes to scientific advice, also participate in briefing of the innovation task force, and take part of delivering advice also after approval and follow up of pharmacovigilance and these kind of things. Also general advice to the community on this kind of products, and of course develop guidelines for ATPs. And then the question to you is, what is the most important committee for ATPs? Is it the PETCO, or is it the Committee for Orphan Medicinal Product, the CHMP, or the Committee for Advanced Therapies? Someone? Then I do it like you do it in Japan and so on, so I go for Theo. Who is it? Which is it? Actually, this is a question that it actually depends on what your focus is really. Because of course, if your focus is to get the final opinion from the CHMP, it is the CHMP. And then you also need to have the approval of the pediatric investigational plan. So at a certain point of time, that is key. And also, if the ATP is orphan, you need to have the orphan designation in order to get the benefits of this designation. But actually, I believe it's the Committee for Advanced Therapies, as they are giving all the advice and prepare the opinion and this kind of things, and also that they are working with classification. I'm trying to put in some questions to keep you awake in the morning. So, and this 18P, it's also defined in the legislation, and there you can see that it's divided into gene therapy medicinal product, somatic cell therapy medicinal product, and tissue engineered products, and also combined 18P, because it's very common nowadays for all kind of medicinal product that you have a combination between a medical device and pharmaceutical, and in this case it's the advanced therapy medicinal product. So this is another way of illustrating this. And as you can see from these slides, there is a lot of different guidelines that is available for those who are developing advanced therapy medicinal product, and those guidelines which are the most important have been indicated in bold text. As I said, it's clear that one of the major roles of this Committee for Advanced Therapy is to help with classification, because you need to have the product classified in order to know how to develop the product. And then it's some questions here, for example, if it's a biological, which could be tricky to decide upon as well, really. And if it's a medicinal product, if it fulfills this requirement, and if it's fulfilled the requirement of 18P, and what type of 18P, and you could have this within 60 days. And you also see there that there is a table on the number of requests for classification that has been submitted, and my conclusion from this statistic is that it's relatively constant between 50 to 75 each year, so you cannot see a trend that it's increasing. And this is some statistics that we have taken from a sister organization called Alliance for Regenerative Medicine, which is quite good of preparing statistics and compare the different regions. And unfortunately for Europe, you can see that there are most developers of gene and cell therapy in North America, and then and the second biggest region is Asia Pacific. And if you look into more details, you can see that China has just got a little bit more developers of gene and cell therapy than Europe. We then go on look into clinical trials for the first half of 2022. You can see that Asia Pacific has most clinical trials, and they also have most of early clinical trials, while unfortunately Europe is lagging behind the other major regions when it comes to clinical trials, and also are fewer early clinical trials in Europe. And there are a number of different reasons, both commercial but also regulatory reasons why we have this unfortunate picture. And then the question is, which region has initiated most cell and gene therapy clinical trials in the first half of 2022? Is it Asia Pacific, North America, or Europe? Actually, I think it's Asia Pacific, but it's close. It's not a big difference really. I mean, the major thing is that Europe is lagging behind, unfortunately. And this is an example of the waste. The big number of approvals that we have seen lately, and on top of that there is also quite a big pipeline. So when you will be working as pharmacist in the future, you will have more and more of these kind of products to deal with, which will be very stimulating for you, I think. So this is a list of different products and also a list of products that has been approved in the first half of 2022, and also indication. From a general point of view, you can see from this that the approvals in the US is much quicker than in Europe, and that is consistent with the rest of product that the US FDA is more efficient and have more resources than the European Medicines Agency, and therefore they are much quicker to get approvals. Finally, we'll talk a little bit about the EFPM activities and also conclusion from this presentation. And yeah, there you have the EFPM mission, which I think it's self-explanatory. And if we then go into more practical details, we have a European Regulatory Affairs and Operations group, and we also have another group of manufacturing and quality expert group, and they are working together in a common team on 18P. And one thing that we have been doing is that we're commenting on the updated regulation on blood tissue and cell, which I think now, the latest version I saw from the Commission is called Substance of Human Origin, and our major task has been to push the Commission not to blur the line between the blood tissue and cell regulation and the 18P regulation, because it's a difference if you just have transplantation compared to if you manipulate the cells, because then it becomes pharmaceutical. There is a revision of the whole EU pharmaceutical strategy and the pharmaceutical legislation. There's a need for specific 18P variation categories. I also developed a joint position paper with our sister organization IFMA, which is the organization for international research-based pharmaceutical industry, and reliance that's about that one authority follows the decision of another authority and do not redo the assessment, and convergence is more about having the same kind of requirements. We are also working in the International Council of Harmonization, which is the basis actually for the global pharmaceutical industry, as they have agreed between the regions on common requirements for drug development and manufacturing. And we have also, of course, given views at the last meeting of the Committee for Advanced Therapy that they had in the industry. One thing that we've been working quite a lot about is simplification of EVO risk assessment process in the EU. And in fact, those who have a good memory from the pandemic know that the Commission decided that you should skip the specific EMO approval for clinical trials when it comes to COVID-19 therapeutics and vaccines. And we are asking for them to skip it for all products, because you have approval of all clinical trials via the regulatory authorities, and you have a specific EMO risk assessment when you submit a product for approval. GMP Annex 1 is on sterile medicinal products, and that is of course important for advanced therapy medicinal products. And as you can see here, the 18Ps are quite complex and requires appropriate regulatory framework. And it's a fast-evolving technology that requires refining the regulatory framework as necessary to keep pace with advancement in technology. And it includes a lot of different modalities, and also one thing that is important is to strike the right balance between proper guidance without hindering development. And by that I mean that it's important that you do not develop very detailed guidance too early, because it could become very prescriptive and hinder the development. On the other hand, we should not wait too long either to develop guidance, because then people who are developing products will not have anything easy to use. And there is a lot of regulatory issues that needs to be addressed, and we see a difference in regulatory standard and requirements. For example, these GMO requirements which I mentioned, where actually each national GMO authority has their own rules as well. So even in Europe we have a challenge to align. And there is also a lot of challenges in the national market, because in several emerging markets the regulators have not developed any guidance for these type of products. So with this, I thank you for your attention, and I hope I have kept the time reasonably well. And before I finish and open up for some questions, if that is okay for the organizers, I would like to thank Dr. Kobe Ho from Hopanarok, who has helped me with drafting this presentation.
Thank you a lot, Mr. Donnell, for this insightful presentation on challenges in regulatory and manufacturing. And now I would like to give the floor to our second speaker, Doctor of Pharmacy, Carlos Montano. The floor is yours.
Thank you. And well done for keep going. Oh, there we go. So, morning everyone. My name is Thanos, and for those familiar with the Marvel Universe movies, I'm not ugly person, and I'm not going to destroy some of the universe. And I also have two 5-year-olds who ask me, why did you push your daughter off the cliff? So, you had a wonderful presentation by Professor Feldman on the advanced therapy and also the regulatory landscape. What I'd like to do is actually address regulatory affairs a bit higher level, try to understand the importance of it and what role it plays in industry, and I will also speak a little bit about omics and advanced therapy. Now, usual caveats about the opinions of the speaker, etc. Now, first of all, I'd like to thank ETSA for being here, and actually ETSA invited TOFA. Now, TOFA is an organization for regulatory affairs professionals. I've been a member my whole professional life, about 16 years today, and it's a wonderful non-profit community. There are many like-minded individuals, there are training courses, there are symposia, there is a monthly magazine about all various topics in reg affairs. And importantly, for some of you, it's a free membership for undergraduate students, and there is a career fair as well. So I'd like to thank TOFA as well for some of the material they shared with me. Now, as I said, I'd like to talk to you about why reg affairs is important in the pharmaceutical industry and what we do as reg affairs professionals. And at the very end, I do have a couple of slides from those who are interested in career in reg affairs. But there is also a workshop in the afternoon. Hopefully, I'll see some of you there, and we'll go in more detail about some of the things that Professor Keller said around the various registration pathways, the product life cycle, clinical trials, and also all the various committees that he also mentioned, the orphan medicinal products, the pediatric regulation, and maybe some of the accelerated pathways to get your drug quicker to the market. Now, what are the key roles for reg affairs? First of all, it's about communicating your benefit rates. This is very important. When the Committee for Human Medicinal Products or any other committee look at the product, they're just trying to see what is the benefit risk balance for your compound. What are the benefits, what are the risks, and then is that positive? Very often this is also communicated in your label, your summary of product characteristics, and your package label as well. And this is where all this hard work culminates, and this is what, once you're in the marketplace, it's the label that will drive the market. Also, it's all about understanding the regulatory requirements. It's not just understanding them, it's also trying to decipher what exactly they mean. What is the impact that it will have in your product development and also in your company? Then, this is a bit of a cliche. We say we are the face of the regulator to our company and the face of our company to the regulator. What this means is that when you have a meeting, with a regulatory agency, you really are an advocate for your development program and what you are trying to do. But also, when you are part of a cross-functional team and you work in your development program, how to put your clinical trial board, how to put your registration dossier together, you play the role of the regulator there. You try to question and critique what we have put in there, why we should go this way and not a different way. So we have a crucial role in drug development, in strategy. It is not just medical or marketing deciding based. Reg Affairs does have a pivotal role. And the last thing I have there is about pharmacovigilance. The hard work really begins once you're in the market. That's when you start getting a lot of real-life data from many patients. And product safety and patient safety is paramount. So many companies, there are dedicated departments just on pharmacovigilance. Now, there are a lot of different things Reg Affairs are involved in. I mentioned strategy, there is documentation review. From simple things like the protocol, your investigator's brochure, or a label, application forms, etc. Also, record maintenance, because there are audits. You may be aware with good manufacturing practices, good laboratory practices, good clinical practices. There are audits, whether these are external from regulatory authorities or internal. So documentation, record maintenance is paramount to this element. Response to queries. Any application you make to regulatory authority, you will probably get questions. You are responsible to bring the team together and put a response that will get you over the hurdle. Advising on changing regulatory environment. Professor Keller told you all the work FDR are doing because we are here talking about innovative products. Regulatory guidelines and regulations, they're in a constant catch-up game with innovation. So we play a big role here, trying to also in a way educate regulatory agencies themselves. They don't know that. Right? So it is also our role to explain our innovative products and how to drive regulatory policy forward. Talking regulatory policy, in many big pharmas, you do see they have specialized people or even departments just specializing in regulatory intelligence and policy. When we talk about regulatory intelligence, we're talking about people who look at all the regulations, guidelines, directives, they collate them, they decipher them, they explain the impact to the company. And when we talk about regulatory policy, it's how do we make an impact? How do we influence regulatory agencies and governments to take regulatory guidelines and regulations to a way that is in line with innovation. And last but not least, participation in industry fora. I mentioned TOCA, there is obviously FDR and many other. It's very crucial to have this cross-fertilization idea. Now, RA has a pivotal role in any industry, especially when you think of innovative products, and we did hear of some examples. It's a huge investment to take these compounds to the market. It's a high-stakes game. You make any mistake, you don't get your product approved, you lose all that investment completely. You're only making money once you're in the marketplace. And also you have to always keep thinking. There is this thing called the patent life. The longer it takes for you to get on the market, eventually you will have generic competition. Or actually another innovator or another company that may get to the market before you. So then you have this right first time approach. You may hear some of the companies saying this. What this means is that they want you to understand the regulatory requirements, what is the precedence, and how we can put together the most competitive package together so we get to the market as quickly as possible and learn from any pitfalls and mistakes. And then lastly, understand the regulatory requirements. When you talk about omics and advanced therapy, as I said, it's a constant catch-up game. We don't have all the answers. Some of those compounds that you see, that you've heard, like Kindred, for example, regulators, they have to learn along the way together with the innovator company. So we have a pivotal role here, not just understanding the regulatory requirements, but also ourselves being more and more rounded professional. We need to have good business acumen, trying to understand marketing, trying to understand clinical operations, the medical, the scientific concept behind innovative compound. So how do you develop a program plan? You start from the claim of the product. When you think of claim of the product, you probably think, yes, I want this product, for example, to clear more than half of my psoriasis. Or I want patients with breast cancer to live much longer. But it is not just that. You have to think about your dose, your nosology. You have to think about your actual target population. Are you going to use this compound in children? You have to think of your safety profile. Then, as Professor Teller said, when you think of advanced therapy products and you think of supply chain and manufacturing, it becomes very challenging. So, together, we put all that package together. Sometimes we call it the target product profile. And this is what drives our product development plan. Then you start liaising with all the other different functions: medical, clinical, med affairs, marketing, market access, pricing and reimbursement, a lot of different groups. And you try to work together and implement this clinical development plan. Once you get your data, you analyze your data, and you may discover there that actually some of the claims that you started off from, you may not be able to substantiate them. Or it might be a pleasant surprise, and actually you have fantastic data, more than what you expected. Then you submit your regulatory dossier to the various authorities around the globe. Hopefully you get approval, and then it doesn't stop there. Then it's all about post-marketing compliance. The variations, you keep your label and your dossier up to date with all the changes, and as I mentioned, there is pharmacovigilance as well. So as you can imagine, we provide input in a lot of different things, from license to manufacturing, pricing, pharmacovigilance, and I mentioned patents, copyright, trademark. You cannot imagine how much work it goes into just finding a simple trade name. It's incredible. And then you submit that trade name, let's say to FDA or EMA, and they have questions, and you keep going back and forth, back and forth. And the reason it is because when doctors with their wonderful handwriting, they write down the trade name, it may look like a different compound. And also, in Europe, we have many different languages. We pronounce, for example, letter Z or double Z in different ways. So you may have some sound-alike issues there. So I think Professor Teller addressed this very well around omics in a simplistic way. I'm thinking of it, you start small from genome, genomics, and you go all the way down to phenomics, the overall phenotype. But do a simple Google search, you'll probably find 20 different omics terms out there. Advanced therapy medicinal products, as I said, it's a constant catch-up game, but there is the committee for advanced therapy, as we've said already, addressing gene therapy, somatic cell therapy, tissue-engineered products. And as you've also heard, the committee for advanced therapy, they play a role in classification. You may go there, is your drug biologic, is it chemical? If it's a biologic, for example, is it really advanced therapy or is it not? Then you can also have scientific advice. What this means is there is a procedure. You can approach EMA, you prepare a briefing document, what your compound is about, and then you ask questions. For example, is my phase 3 trial for registration appropriate? Is my statistics appropriate? What about my target population? What about my posology? What about my non-clinical package? Then you may have manufacturing questions, which in the case of advanced therapy, will be very important. And then, of course, CAD, they contribute to the evaluation of your dossier and, of course, the various guidelines and guidance documents. So, as you can see, regulatory affairs is a very versatile profession, and it depends where you are. You may be in a hospital setting, you will be mainly working on clinical trials. You are in industry, you will be looking at the compounds from bench to the training to the market. You may be part of a clinical research organization where all the different companies, they are essentially your client for all the different hospitals. It might be different departments in disciplines. So in reg affairs, individuals who they have expertise in manufacturing, we normally refer to them as reg affairs CMC. I do not have great expertise in CMC, but it's a dedicated discipline there. Then there are people who might be focused in labeling, regulatory intelligence and policy, pharmacovigilance. Sometimes we even see a division in some companies where there are people who deal with marketed products. So basically they submit variations, so these are changes to your license. And then there are people who work in development products, those who take a product from bench to the clinic and do first registration. Now, what would you need for a reg affair? You would need a science degree, you would need a good understanding of a product life cycle, but everything else you learn along the way. There really isn't, I think, an undergraduate degree in reg affairs. Even postgraduate, I think there is one or two master's courses and that's it. So you learn a lot of the things on the job, but what is important is all the soft skills that you accumulate along the way, along your academic career. So when I finished my PhD in cell biology, and then I got into reg affairs, I thought, oh great, I will only use 1% of my knowledge. But you need negotiation skills, time management, project management, strategy, influencing. All of those things you accumulate during your academic career and you do not even realize it. And then you polish them more and more once you're there. Currently, I'm a global regulatory affairs lead for GE Healthcare, and basically our main role is we lead submissions in health authority interactions. We develop, negotiate, and advocate for RA strategy, and we inform and interpret guidance regulations. We are also an honest broker. Going back to what I said earlier, we are the face of the regulator to the company, and the face of the company to the regulator. And what we try to do, we always try to negotiate and find the best solution for a compound. The regulator, they may disagree with certain things we may have in our dossier, in our label. We will push back on certain things, we will accept other things. It's a constant back and forth. And that's what I mean by being an honest broker. So, that's it. Thank you very much. Hope I see someone in the
Thank you a lot for this amazing presentation. So before we go to the next point, I would like to, we will have a quick exercise, and I would like to ask you all for standing up for a minute. Okay, so you can like shake your hands, your legs. So I will be asking you questions now, and if the answer for my question is yes, you should sit down. Okay, so my first question is it your first EFSA event? Okay, so my second question, is it your second EFSA event? Okay, we have more people sitting down. So, third EFSA event. Yes. Okay, so we are going to the next fourth EFSA event. Okay, we have more people sitting down. Fifth EFSA event. Sixth. Okay, so 7. Okay, we have one. Nita, you mind? Oh, we have one person. Okay, great. Thank you, everyone. Now we will move to the next presentation. We have Dr. Burns. Could you please? Okay. Despina Martiraki, and she will present us health technology assessment in pharmacoeconomics for advanced therapies.
So good morning, everybody. I'm very happy that I'm between you. I would like to apologize for my voice because I'm just come directly from the pharmacy department in the hospital as I was in a 24-hour duty directly. So that's why I have to have the help of my notes and say something like that because it's a difficult day for a lady around 60. Okay. So thank you very, very much the organizing committee that give us as the European Association of Hospital Pharmacy and me personally as the president of an Hellenic Association of Hospital Pharmacy to be with you and take some of fresh of you and have the choice to check what do you know about all things that we are going to share in the next slides. Oh, it's not mine. It's not mine. Up. So nothing to declare except my faith to the Hippocrates oath. I feel that we say all of us this too. Just a few points of the issues that I'm going to share with you. Some very short introduction to advanced therapies, some deeper on position paper of EHP on advanced therapies, medicinal products. Let's see what do we know about pharmacoeconomics and HCA. Consideration on EHCA procedure for advanced therapeutic products, and of course, at the end, before the noon lunch, some food for thought. So, if you see at this slide on the left, you see that in the last eight years, how fast went the things from the classical therapies when on 1940. Now in 2020, we are in the future of fusions and the evolution of therapy, and we are in the use of personalized medicines and advanced therapy. 80 years, if you make the things regarding how many years are you in the study and in the faculty, see how many generations through all this from classical to HCP. I was in the university at the early 1980, and I came in at the 1981. All of this was, like I was in the health, and all this was in Aphrodite or somewhere else, not even ours. So in the second part, you can see the list of the approval for EHPs from 2015 to 2022, and this is show us the current situation and the future directions for the therapeutic. Now, here we can see some categorization of EHP, but you have already heard about that, and already have been mentioned for our previous speaker with more examples. That's what I would like to remember is that we have to understand the nature of its category. I mean, we have gene therapy, we have medicinal products of gene therapy, we have somatic cell therapeutic products, we have tissues, and we have combined SAD and PIS. So let's just give a cycle of personalized medicine, taking the example of CAR-T cell therapy. This is where we can see the complexity of things regarding the example of this one, monitoring effectively all the immediate steps. As said, this is a challenge for involved healthcare personnel, not only medicine but also pharmacists, during designing and details the clinical trial procedure. Moreover, when working with marketing personalized medicinal products in real-time conditions, the dedicated staff, as doctors and pharmacists, must excel every time in order to ensure that patients benefit and that there is no waste of resources. Something that's very crucial, especially in this time of crisis, economical crisis, and all other crises that are in front of us. So, and let's go closer to the hospital pharmacies. How many of you have a full idea what the hospital pharmacies do? How many? Really know the work that the hospital pharmacists do in the hospital area? Oh, if you don't know what the hospital pharmacists do in a hospital, it's difficult to share with you all the next slides that are going to follow. Okay? But let's try through these slides to have a more close introduction to hospital pharmacists and their everyday job. So, this is the position paper. Is a very new position paper. That means it's something that we develop what we believe on this specific area on advanced therapy medicinal products and give the role and the responsibility of a hospital pharmacist in this area, giving the education and the training that are needed in order to develop these medication products, and of course, always, not only in the hospital area, but in any area where we work, we need to have an assessment of our work on this specific area, and in this, and for this position paper, this one is the ADMPs and the pharmacoeconomics. If you want to go closer and deeper on all these issues, you can go to the EHP site and have some more research on that. So let's see the first field, the role and responsibilities of the hospital pharmacists in the ADMP handling. As hospital pharmacists, we are responsible to ensure the safe and the effective use of ADMPs in a holistic model. In the real world, we are every time we are responsible and ensure the safe and effectiveness of any medication that we have to develop for our patients, even if they are in hospital, meaning inpatients, even if they are coming to us as outpatients for daily treatment or for taking the medication for some rare diseases or probably for HIV diseases or probably for something like that, chronic disease. So we think the multidisciplinary team that we are working with for all marketing therapies, we are involved in a lot of things. What's this? The decision and audit management, the medication management, the positive status of the hospital production and reconstitution, because a lot of these products have to be prepared in the hospital. Some slides ago, you heard about regulatory. It's very crucial to be close to the law as pharmacists, as faculty, as professional association, in order to achieve what we need. Because this is a field that a lot of other healthcare professionals, for example, doctors or biologists, fight for. Don't forget that this is medical, this is medicine. They have to have the approval of European or national authorities. So everything that is going through this pathway is medicine. Who else knows and who else can develop a medication therapy better than pharmacists? Please I want to see answers. Do you feel strong to develop with us? Yes. You have to be strong from now to be stronger in the future. Okay. So, see, reconstitution, storage, administration, cleaning, waste management, a lot of waste management in this time. Pharmacovigilance, training of all dedicated personnel, meaning nurses, meaning doctors, meaning other staff, cleaners, for example, all people who are linked in this issue. And of course, clinical follow-up of patients. Also, we are responsible to implement all procedures according to national and international standards. Because we have to remember that everything we are doing in the daily life, in the daily professional life, it has to follow this procedure according to the national standards and law, ensuring that the necessary number of properly trained staff there is. So, in order to work for the safety of our patients, we need the right number of personnel, and personnel that is well being training and who is validated for that. And also, what else we need? We need personnel, and we also need money. Okay, because with no funding, we cannot do anything. So, second part, education and training concerning this area of ATPs. It's why do we have to concern about that? Because we need to assist members in demanding needs for relevant education and training of healthcare professionals. Our association has set up a special interest group which is focused in this area. If you go to the site of VHP, you can see that a lot of special interest group has arisen in the last 2 years, was very focused in specific areas. One of these are the HLVs, and that's why, because we want to have in the preparedness for our colleagues for in vivo gene therapy medicinal products. The role of this committee is to develop the best practices around Europe and give guidance material for the healthcare professionals, not only pharmacists, but also nurses, doctors, etc., who are working in the multidisciplinary team. And the requirement of all this training is always be approved by the European Association for Medicine. In this sense, I would like to underline that pharmacy school and professional bodies, I mean faculty and associations like ours, should offer continuing educations and integrated training of pharmacists for this area on everything else that is in our daily life in the summer programs. You are very likely that we can be here in the next Congress. In my years, my first Congress was in 1993, and I ended my faculty in 1987. I was working for 6 years, and then I had the opportunity to go in the Congress and give back for what's happening in my country all around. So you have a very big opportunity, and you have not to leave it to go to the field. Patients, the carers, and family members, the patient group representatives are also very closely involved in the holistic management of these products. And so the communication and information sharing is a must. And if we can go like that, things can be better, things can be faster, things can be in more global ways. Assessment of these therapies and of course pharmacoeconomics. The assessment of the HCP should follow the same principles that we have in a regular medication software system, in which the decisions are based in health technology assessment criteria and of course evidence-based. Okay. we as hospital pharmacists, we have the leading role in the hospital of the drug and therapeutic committee and the committee of pharmacovigilance. Every hospital has a committee like that, and every committee has a hospital pharmacist as limited by law. So in other ways, if you go out of the hospital, a lot of hospitals around Europe participate in central, regional, or national negotiating procedures, not only for ATMPs, but all categories of medication are an individual asset in assessment of ATMPs and other medication, and of course on pharmacoeconomics. And our expertise is very much involved in further, furthermore, it's very crucial because we are the end user. We are the end user before the patient, and we are the end user who can evaluate before and after. It's a crucial role in all this disciplinary group. So due to the exceptional force that all this project we are talking about for very expensive therapies. And so we have to be very well known in order to keep our options and to evaluate in the right way. That means that not all of us specialization in so here you can see some levels of the evidence for pharmacoeconomics. You see how many sources we have, the 9 sources, and this specific feature that we have to follow when we evaluate the strength of the evidence, if we are a high one or a low one. So that's so. And the crucial question, how much will impose? There are a lot of options to reach this place. How much does it cost to acquire the drug in one patient? How much does it cost to treat one patient, including the facility, the provider, the protection population? How much will it cost the providers to treat all eligible patients for a year? Providers and we, for example, the insurance, public or private. How much will state providers programs pay to send patients out of state when needed, for example, in a country or in a region, probably there is not a hospital or an excellent place to use this. For example, I'm going to give another example, which is more recent. A lot of people who have cancer in Greece, for example, lives in islands. In Greece, we have a lot of islands. Not every island has a hospital, and not every hospital in every there is an island that it has an oncologist or an hematologist who can develop the medication. This is a problem because these patients has to travel in Athens, in Thessaloniki, in big centers where big hospitals with all this specialization exist and can develop this. So if we have this problem for things that we have to develop in 1940, just evaluate with yourself and your mind what have we do, how many problems we have to skip when we are talking about this personalized type of medication. So the evaluation of the person is to check the impact and to check the impact and to understand the importance of this impact. I don't know if you can understand what do we mean by pricing and reimbursement. What we mean about collateral cost. When we are talking about pharmacoeconomics, this is words that we have to understand the meaning of this pricing. There are medications that in the UK we can buy in a very lower price, for example, than Canada. You saw previous slide who showed in which area of the planet were more and where we have more therapies of advanced HCMPs, and Europe was in the third, and Asia was in the first, and I don't remember which part of was Asia, North America, and if we can go and check the insurance that in every state there is, for example, in Greece, most of this type of therapies and most of the expensive therapies have a very good access to the patients. We have a very good access, don't we agree? If you go, for example, in Canada or in America, where other type of insurance there is, you see that a lot of things are very costly, they have bigger prices, and not reimbursements. So what that means? That means that this big price and low reimbursements make the accessibility not available to a big number of patients. So when we are talking about evaluation of the cost, we don't say, oh, this one cost 1,000 euros, this one cost 500 euros. There is a possibility the one with 500 at the end cost more than the 1,000. So that's why we have to have the HTA, the health technology assessment. What is the health technology assessment? In simple words, it's a multidisciplinary activity that means something that a lot of people and of different type of education, doctors, pharmacists, pharmacobiology, pharmacoeconomists, social lawyers, for example, and these patients. Okay, so this committee and this organization, this association, has parts from different parts of the real world, and that's why this committee has to systematically examine the technical performance, the safety, the clinical efficacy and effectiveness, the cost and the cost effectiveness, the organization implementation, the social consequence, the legal, the ethical consideration of the health technology. As you understand, a doctor cannot do all of this, a pharmacist cannot do all of this, a lawyer cannot do all of this, a priest, because a lot of these committees sometimes have also a priest in, cannot access and evaluate all this. That's why we need all of them together. It is a form of policy research with specific methodology which examines the short and the long-term consequence of the application of a healthcare technology in order to inform the policy decision making. And what is the policy decision making? Usually is the government, is the authorities, is the one who is going to check the cost and the reimbursement and enable rational decisions in order to be made for the healthcare research allocation. I don't go deeper to this. I just say that EU-NETA is a joint action between the EU and the national bodies who are working in the HTA. He works on right now on making a centralized regulation who makes some fields more available and more fast to access. If you want to see what EU-NETA is doing, go to the internet, Google, and find a lot of information about it. So, a lot of technology domain has to be described and has to be evaluated in every product in order to have a global and a good evaluation. From all these domains, The last one was the personal recommendation that came in the last year, because we needed to develop our money in the best way in order to have bigger access for a bigger stable of patients. So, before going down in the other side, I want to go and have a big question in ourselves. Is the advanced therapy under consideration in curative therapy? What do you think? As you can understand, because this is not something that the classical way, you go to the lab, you have a molecular, you work on it, you make, you know, you make experience, and then you take a final product. Is the advanced therapy in this category? What do you believe?
Yes.
Is? Even if it's not happening in a lab? Yes, it is. Because it is a therapy. It's in, we take another path, right? But we have to know how to respect this path. We have to know how to understand this path, the problems and the development. Is the advanced therapy under consideration examined in an end of life context? What do you think? Remember, it's a medication. How does the AHA mechanism appraise the value for hope? Because when we have to develop a new medication, why do we do that? Because we want to do something better for patients who have do everything. And there is nothing active for that in front of them. So the value of hope for patients family, for the researchers, from doctors or pharmacists, is very big. When the declining patient may be willing to buy himself, because patients say, okay, I do everything. Whatever it costs, my life costs more. So I give up anything. Or to take immediate mortality risk decision, because we never know if the next steps go to the better or go right. So, all of this has to be very quick in our mind by the significant stage of increasing the long-term survival. Because what all the researchers and healthcare professionals want to have long-term and quality in this long term. This is our main scope. However, advanced therapies are uncertain regarding long-term outcomes. You have to remind that because it's very new. So we don't have a lot of clinical trials results like we have in classical medication. And of course, we never have to stop to have in our criteria the limited budget. What that means? That means that it has to be a prioritization, and ATMPs probably they have to have a distinct budget because they are very expensive, and one therapy or ATMPs may be in the other parts. And there are 1,000 therapies for 1,000 people. So 1,000 people. So we have, to check the balance between these two diseases. So if we don't have budget limit, how do we assure the access to innovation for other patients? Because innovation is not only there are other new products too. So let's take the regulation promotes three things: the real world evidence infrastructure, the new early dialogue opportunity, and the timely and effective access advanced healthcare for all EU patients, as this category are most often delivered through centers of excellence. Not all hospitals can develop this type because we need specific rooms, specific and training personnel, and good budget. So it's usually big university hospitals are going first to develop this type of therapies. Now, what is considered the value varies between decision makers, the suppliers, the payers, and the patients. The heterogeneity in value assessment systems across Europe is significant differences in coverage recommendation across sector based on how the HTA agencies perceive and even bring evidence and the associated uncertainties. What that means? That means that every country at the moment has a different HTA system development. Some countries who are steps in front have made the association for technology assessment years ago. Some other countries, like my country, are working on this the last 5 to 6 years. So in order to have an association, you need to have, for example, 200 people, researchers and the other, to work on this only area. The committee is about 10 to 20 people, so you can understand how fast can go one and how fast can go the other. And that's why the recent recommendation that I said before is going to find some links in order to be this type of links to can be used by all countries, and that makes things easier. That means one evaluation can use in another country, and there will be only a few or less parties that have to be argued in the national level. The framework was used by ITA agencies are typically based in a cost-utility analysis or cost-effectiveness analysis. I think that in the relevant lessons in the university, you that are in the end of your studies, you understand what the meaning of this. As the main method of determining the value of new technologies, not only this, but all the technologies. And sometimes this involves reflecting the health gain as quality adjust, like here, you have here the word quality, or an alternative basic relevant outcome. The example is like here that we have gain. How many more years can someone live but in a good position? Other parameters like the gravity and severity of the disease or the patient stage, onset and lifetime burden treatments, and they may be also taken into our account. So new payment models. We need new payment models in order to ensure fast access to innovation, because all these new innovations are very costly. So we have to earn the money in order to go on, and also we have to ensure the sustainability of the healthcare system. Because if we don't go in logical way, we take the seat where make it done. Right? So without the adoption of all these new models, some transformative therapies may not reach the patient. And if we don't have a good developed, not some, but the most European countries have this problem. So the innovative access and the funding include the pay for performance, the progressive payments, and the special fund for the transformative treatment. So that's a few minutes before the end. What I would like to keep in mind, hospital pharmacists are responsible for the holistic management of any medication therapy, including EAMPs, being involved as member of the multidisciplinary team in the hospital or video area of your system, in all relevant clinical steps and the procedures. Our involvement in pharmacoeconomics and the THCA is even more crucial day by day, due to the exceptional cost that we have to develop, the sensitive handling, and remember public and all the other conditions, and of course, the special character of this medication treatment. The development of the registries of the APs is collect long-term data Ideally, this should be international, independent, or specific technologies and manufacturers, patient population, and also indications. The HTA decision makers have to access personalized advanced therapies without knowing the actual final cost, because now we're checking and we are in this part, we don't have final certain cost results on long-term outcomes for patients. And the dedicated and separate budget for this type of management could be more appropriate for monitoring the cost, so the reimbursement of the suppliers links to actual results and links to real data, real life data. Value may not currently be adequately captured in the calculator of qualities, but we have to consider that which include the valuation of the cure, that means social value because beyond the health gain, and what patients prefer for treatment before beyond health gain, and that means ethical issues, not only economical, not only scientific, but also ethical issues. The value of spillovers into innovation as non-predicted benefit. For example, in the way of setting this, probably we find a new diagnostic tool who give us the possibility to ask the response to advanced therapy, and something that can try and give us an extra. And rapid development of European education and creative material is of almost important regarding all the aspects of ADHD, because you have to remember that they will soon replace the majority of the classical treatment day by day. So, in order to be there and in order to be a player in this action, a defined change in the context of the study programs in pharmacy school is, in my opinion, mandatory in order to keep promoting patients' benefit and preserving health system resources. And of course, we need to have collaboration, communication, brainstorming between faculties, professional associations, in all steps. We cannot be a pharmacist if we not be prepared for this. That means you cannot be a good community pharmacist, you cannot be a good research pharmacist, you cannot be a good hospital pharmacist if you don't take and if you give you all the opportunities that you need to have all that we need to be a good one in every field. So I hope it was a little bit interesting. Thank you very much for your attention. Thank you for good time to enjoy our capital. I hope that I have some years for retiring, but I believe that we are going to be together in a field of hospital interest or a field of pharmacist interest in general. Thank you, and if any question or something that I missed, please don't hesitate to go on. Thank you very much.
Sorry, I have
So it works. I will clarify one thing. After a break, we'll have a Q&A session, so you will be able to ask questions to all the speakers.
So if I take the opportunity, because I have to fly to Brussels, I have a very time. So if there is a question, probably for me, I will appreciate it to be now, because I don't want to leave and leave behind me questions. Please, I can, okay? So please.
I was housing in hospitals here, and do you have this position as also clinical pharmacist or only?
Where are you coming from?
Sorry?
Where are you coming from?
From Lithuania.
From?
Lithuania.
Lithuania is one of my portfolio countries. I love Lithuania. So in Greece, we have a master's degree in clinical pharmacy. we don't have the specialization of hospital pharmacy coming from the faculty, not even other specializations, for example, community pharmacies. But for the hospital specialization, we are working and we have the positive opinion of the Central Health Committee of the Ministry since 1217. So right now, we are very close because by law, pharmacists who are going to work in a coastal area after the 3 first years call it coastal pharmacy. But, you know, okay, I'm a coastal pharmacist, and because I'm working 36 years, I'm also the director of pharmaceutical services. Even if I have the clinical pharmacy degree and 2 pharmacoeconomics degrees, this is not giving nothing extra. It's only the years. And so right now, we work as an association on this. Also, European Association of Hospital Pharmacy, working in this with, if you have read the statements of our association, give, you know, the field in which every hospital pharmacist has to work. And there are a lot of tools are given, not only for hospital pharmacists, but also for hospital managers and also countries' decision makers to understand why it's so valuable to have the specialization. Because you earn a lot of things, you earn safety for the patient, and also you earn money by coming from the involvement of other professionals like nurses or like doctors who make sometimes your job. So this is the one part of the association, the European Association, and the other part that we are organizing right now is the workforce of the hospital pharmacy specialization. And what that means what the faculty is really doing to give more of the needed number of the hospital pharmacists, and what are doing the governments to have the appropriate number of professionals, of experts in the field of the hospital area. So this is something new, this is something very interesting, and I think that it will be something very helpful for you too as students. But if you leave me to make a small comment, because you are students, and you have to understand that you have to fight for what you want to be tomorrow. So you have to ask for all the opportunities. Because, for example, in Greece, the most classical is the research area, but we don't have a lot of industry. And in industry, there are more chemists than pharmacists. Okay? We have a faculty with a lot of analysis, synthesis, and all the others. We don't have, for example, pharmaceutical care as a main course. We need it as pharmacists, wherever we are, even if we are in the community, even if we are in a hospital, we need it. And so some things like that are big stones in the excellencies of our professional, and I think it's something that countries like yours staying with me. But there are other countries, like, for example, Spain, who has the specialization, which was Spain. Okay, so you have to say, I'm telling the truth, you have to say that. So they have the specialization in hospital pharmacy around 33 years. And coming from the faculty, because now we are trying to make the courses for the people who work in the hospital area in order to have all the knowledge that they need to be real hospital pharmacists. Because a good thing that we have in Greece is that we have good law who support our, what we want to do. The problem is that we don't have the good feedback. Or the feedback, it can be a good feedback, but not for this field. So I think that in the area, and you we should have a scope on this, to have a common scope. To have to make the faculty give you all the possible opportunities, not only as reference or as information, but as real time, real practice, to check what I want to do, what it's going to be.
Thank you very much.
You have your question.
Thank you very much, Ms. Rakilaki, for this insightful presentation about assessment management and pharmacoeconomics of advanced therapies. Now we will move to the last presentation during this symposium speech, and I would like to give the floor to Professor George Patrinos, Professor of Pharmacogenomics and Professor of Biotechnology in the University of Paris.
Okay, so thanks so much. Great being in Athens. Welcome all to Athens. Hope you enjoy your stay. It's going to be a short one, but I'm sure you'll find ways to enjoy yourself, not just professionally, but also socially. This morning I'll try to give you an overview as soon as the screen goes live about ethics, and specifically about how ethics can be implemented in personalized medicine, in genomics. Just take a break. I'm sure you're all tired on the previous talks. Okay, thank you. Right, so as I said, the one with this one. Quickly show me how it switched on. Oh, okay, and is there a pointer for this one? Yes. Okay, so ethics in genetics is going to be the title of the next 25 minutes, 25 minutes, relatively short. Right, personalized medicine. The term stems from this country. When Hippocrates said that it's more important to know what type of person suffers from a certain disease than knowing from which disease someone suffers. So it could look close to what personalized medicine is about. And since we're in Greece, and I'm Greek myself, I usually have this paradigm of how we could compare the transition of personalized medicine from the bench to the bedside, from research to the clinic. So if we consider that we have a vast amount of evidence, like results, papers that have been published throughout the years, and we need to move to the top of the temple, which is the implementation of genomic medicine. For that, we need pillars. One such pillar would be capacity building, in the sense that we need instruments, we need technology, we need to build advanced technology to be able to exploit the richness of our genetic potential. We need to have ethics, which we're going to be discussing together in the next slides. We need to have informatics. We need to have tools that would translate genetic information in the format that clinicians can understand. We need to have, we need to raise the genomics awareness of the general public. Because at the end of the day, it's not just healthcare professionals, it's also the general public that needs to understand what genetic medicine is about. Educating healthcare professionals is basically what we're doing here. You're the next generation of healthcare professionals, and you need to be duly educated. And last but not least, economics. We heard this, the last talk about economics, we heard that there's no such evidence of personalized medicine. This is not accurate. We have evidence. We have evidence since 2015 about how personalized medicine could be, about cost and effectiveness. We have interventions that are cost effective, we have interventions that are dominant, which means cheaper or better. So we only need that this information is put into action and how this would be put in the context of reimbursement of healthcare technology so that it can move closer to the patient. So, ethics. That is what we're going to be discussing in the next slides. Ethics so genetics is a complex word that comes from the words genetics and ethics. So it's not genetics, it's genetics. And when it comes to ethics, we discuss about 3 types of genetic tests. The audience from Patras, they have to excuse me because some of those slides you probably have heard during our 2nd year ethics course. But the majority, I guess, are not. So there was a movie several years ago, The Good, the Bad, and the Ugly. So I thought, why not exploiting this catchy title of making some kind of an analogy in the genetic test? So we have 3 types of genetic tests. We have the good, the bad, and the ugly. The good genetic test is those tests that they are referring to diagnosing genetic diseases, monogenic genetic diseases, and also individualized treatment. We also have the bad, which are the predictive genomic, whatever predictive means. It's polygenic diseases, lifestyle genomics, athletic genetics, and so on. Something that we don't have sufficient evidence, sufficient knowledge. And lastly, the ugly. Genetic tests that we have very solid evidence, but they lack ethical approval. They are, let's say, ethically questionable. Such tests are the infidelity genetic tests. We're going to come to this slide in a minute. So, pharmacogenomics. How we could exploit our genetic potential to understand how a drug responds on us in terms of efficacy and toxicity. That's a very oldie slide. Patient group. Patients that they have been diagnosed with the same disease, same prescription, same drug, same dose. Some of the, for a majority of patients, or for a fraction of the patients, the drug will be beneficial and non-toxic. You're going to have a fraction of patients in yellow for whom the drug is going to be neither toxic nor beneficial. You have a group of patients that they will develop ADRs, regardless if the drug is going to be beneficial or not. And the side effects would be mild, moderate, or lethal. For example, acute myelosuppression in ALL patients. And why those tests are good? Because you have solid evidence and approval by regulatory bodies, FDA, EMA, and national medicines authorities. For example, you see the use of warfarin here. You have this particular table in which you see that you can rationalize drug dose based on the genetic profile. And that's the only case of warfarin treatment that you can specifically adjust the drug dose based on the genetic profile of an individual. And that's something that has been put in action from the FDA several years now. And the same is true for 300 of the most commonly prescribed drugs. So pharmacogenomics is not for everything. Okay, it's only for those drugs that are approved by regulatory bodies. So, contrary, let's go down to the bad tests. We have the monogenic disease, which, as we said, are the good. And why they're good? Because it's black and white. But you also have the bad genetic test that goes for multifactorial diseases. And why is that? Because regardless if you are homozygous or a carrier of a genetic variant, the possibility of developing type 2 diabetes is the same. Okay? So it doesn't really mean if you are heterozygous, homozygous, normal, homozygous, mutant for a genetic variant, the result is going to be the same. And that's why it's bad, because it's not black and white, it's gray. Not just in 50 shades, right? In more than that. So you have a large amount of papers that make associations between the clinical profile and the genetic variants. Thousands of papers, okay? And in major journals, for example, this particular one is in the New England Journal of Medicine. It has an impact factor of 192. And based on those particular papers, you have companies. As you see in the top left, companies that they are grouped in two different categories. The first categories are those companies that they test specific polymorphisms, specific variants in the genome. 10 genes, 20 polymorphs, 20 genes, 50 genetic polymorphs, and so on. So they focus on selling tests to their clientele, which is basically us, okay, on the health of the heart, for example, cardiogenomic profile, bone health, osteogenomic profile, cancer, be it inherited or sporadic, enhanced-based genetic panel. I have no idea what this means. Genoscore, personal DNA starter kit, and the like. And in principle, those companies focus on lifestyle and nutritional recommendation. It goes even further. You can go to personality genetic test, and go to the happiness genetic test for Christ's sake, and so on. Then you have the second group of companies. Those companies are selling genetic tests doing associations. And how they do that? They do a genome-wide analysis using chips, using microarrays that include analysis in simultaneous analysis of 300,000 up to 2.5 million of genetic tests. And they provide risk prediction, the so-called polygenic risk score, or PRS. And that's a very catchy word that sells a lot lately and means nothing. Believe me, they mean nothing. They make many people rich, especially many Greek telegeneticists recently, during the COVID era. So those companies are the well-known 23andMe. It's a subsidiary of Google, and they use this very catchy advertisement like democratization of personal genomics. You have Decode Me, a subsidiary of Decode Genetics in Iceland, and then you have Navigenics. Okay? So, a few years ago, several years ago actually, a journalist sent his DNA to two of these companies. He got the results, and he wrote this very interesting article, "The rival genetic test requires compute." Why did he write this article? Because he noticed, according to the results he received, using the very same genetic material, his own genetic material, that company A told him that he has 91% lower risk of developing exfoliation glaucoma, and company B told him that he has 3.6-fold more chances of developing the same disease. And the same goes for a large list of those particular associations. And keep in mind that those are associations. So it's like associating the variant with the disease. Okay? So all these PRS, all these, polygenic risk score, how accurate are they? Let's see. We discussed the issue of monogenic disease. And why is that? Because it's a single gene, or the interplay between the gene and the environment. For polygenic diseases, for complex diseases, you may have 4 genes, 8 genes, 12 genes, 16, 100 genes. For example, height, which is a physiological trait, it's determined by 192 genes, including the environment, nutrition, altitude, oxygen concentration, and so on. So, if you have all the component of the genetic, of the interplay between genes and environment, you may be in a position to determine not risk, but certainty. The word risk is something that it's put there just to capture the fact that you may be wrong. Okay? So somebody has given his money for nothing. Right? So let's say now that we don't know exactly the genetic composition that refers to genetic disease or a complex disease. We don't know how many genes, we don't know how many, let's say, environmental factors contribute to this particular phenotype. How could we possibly determine the risk or the certainty of developing a disease? To put it plainly, if we have this jigsaw puzzle that consists of 500 pieces and we only know we only have 100 of them, how could we see the full picture? It's a rhetorical question. And of course, in this case, there has been a paper, a study has been run. Some scientists used biomarkers, conventional biomarkers like age, systolic blood pressure, hypertensive medication, and so on. And the second model, which I'm sorry for being in Greek, it has the same conventional biomarkers and 11 genetic biomarkers that have been selected from a panel of very well defined association between genetics and phenotype. And what we see is that in this case, no matter if you use the conventional biomarkers or the conventional in addition to the molecular biomarkers, the difference is negligible. 2 in 1,000 in Caucasians and 1% in African Americans. Bottom line, today we cannot really use PRS, polygenic risk score, simply to tell a difference between the development of disease, polygenic disease or not. Whoever believes otherwise, okay, I'm not going to into the sentence. I think it's clear. Now, let's look at the ugly. The infidelity genetic test. Okay, there are several companies that they sell this particular service, if I may call it this as a service, in Greece and abroad, both in Athens and elsewhere. So, what do? They use cutlery, they use cutlery here, bottles, brushes, cigars, and they use it to tell if your genetic material matches the one that is on those particular items. And the poor guy, 10 years ago, I have the English translation of that. He brought his mattress from home because he was suspecting his wife of cheating on him. And a particular company in Athens ran the analysis and identified 8 different male spots. Okay? Certainly, those particular individuals were not asked for their consent to be analyzed. As such, this test is exactly accurate, but on the other hand, is ethically questionable. Okay? So, according to the studies we ran in Greece for the last 10 years, even the one that has been published in Nature Reviews in Genetics 10 years ago, there are these types of genetic tests that they run in the more than 30 genetic laboratories in Athens, in Greece, but also elsewhere, not just the capital. And here, you see how these tests can be categorized. You see, for example, paternity test, which could be green, good, or gray, ugly. And how this can be determined, because the companies now do not call it infidelity test. They call it genetic match, just to make it lighter, you know. But the problem here goes whether you have consent or not. Because the means of performing the genetic analysis is virtually the same. You have genetic tests for athletic performance, for Christ's sake, nutrigenomic tests, genetic tests for aging. And you have more, because this study was run in 2014. You may have tests that determine personality, if you have a good personality or not. You have a test determining if you are going to be happy or not. Okay? It's a happiness gene, in case you're not aware of that. And so on. You see, for example, DNA fit. We also have the Athens Marathon in 10 days, so it could be quite helpful, I guess. You see DNA tests, nutrigenomics and epigenetics. I doubt that these guys know what epigenetics is about. So what we did, just to speak with proof, because that's what we like to do in our lab, we performed a meta-analysis, and what we did specifically from Christiana Pavlidis, which unfortunately, after she assumed an academic position in Britain, she passed away 3 years ago. We studied almost over 500,000 individuals in 1,170 studies involving 38 genes. So the sample was relatively okay. And we determined, using a meta-analysis, which is a tool to demonstrate correlation or not between the various studies that we put in the same bucket, that no specific or statistically significant association was identified in any of the 38 genes that were sold by specific companies here in Greece. And as such, commercially available genomic tests cannot be presently recommended. It's not what we say alone, but that's also the position of the American Academy for Nutrition and Dietetics, who they believe that although this is an emerging discipline, it's not ready for clinical use. So make no mistake about it. We're dealing with evidence, we're dealing with genetics, with genomics, and even if we feel that we understand, we still have a long way to go until we get the full picture. And it can go even worse. Gattaca. Those that they have a specific genetic profile will not mingle with people with inferior genetic profile. We're not that far away to have this. We have the retail DNA test several years ago from Time magazine. We have dates based on spit. When in doubt, spit it out. So how you make a match? You think that's impossible? Oh yes, it happened. It happened during the New York Fashion Week, organized by this lady here. A spit party, using that particular invention that we saw in the previous slide. We have this very smeary picture that you can put above your bed. Okay? So, where we are today, that's our genetic composition. And that's a book written in Estonian. I'm not sure if we have Estonian participants in the audience, but we don't. Okay. So, I don't know Estonian, of course. I can get some words like security and mobile computing. I understand that's in English. Okay, that's fine. I can suspect the meaning of some of those other words like Erasmus Mundus Programmi, which most likely is Erasmus Mundus program. Okay? But there are other words, I have no idea what they say. Okay? So that's where we are with the genetic profile at present. We know that we have 3 billion base pairs. We know that we understand few thousand genes, like 3,000-4,000 genes. We have, even today, we have the open reading frames, we call them ORFs. So sequences, primary sequences that we know that they possibly encode a gene, but we don't know which gene would they encode because we haven't found the protein that they encode. So this is where we are at the moment. It is really naive if we feel that we decoded the primary sequence of our genome and we automatically understood what does it mean. Okay, so it takes a lot of time and energy to go and decipher how this information could be translated in our health and disease. So, tip of the iceberg, not just the genetics information that we know, but what I've shown you today about the ethical considerations of genomic medicine. Believe me, it is much worse than that. So, just leaving you as a food for thought, we should be extremely cautious when we hear advertisements from those particular companies selling tests that it has a huge potential for health, but they're not ready yet for clinical implementation. So I'm not deflating the whole effort. I'm a geneticist myself. I wouldn't do so, but I'm just raising a red flag, saying to you that you should be extremely cautious when you hear companies advising you for your own health, supposedly, to buy their services. So, I wish to finish by acknowledging the European grants that funded our work, especially this particular one, Cost Chip Meat, that provided the means of of performing this type of analysis, and thank you so much for your attention.
Thank you, Professor, for your interesting presentation. Now we will be finishing this session of Symposium. Yes, we have panel discussion in the second part of the Symposium. And here you can see the same number we had for Slido, so you can already start asking questions on Slido, and we will start answering questions after the break. So now you have the break. Please be back here at 11:40 sharp. Enjoy your coffee break. Thank you.